Today I shall discuss about test of soil. A test is worth than 1,000 wise opinion. So this sentence implies the importance of a test, importance of this test. Normally in our geotechnical engineering works, some important laboratory tests are useful for practical application. These are in-place soil moisture content, unit weight or soil density, specific gravity, particle sizes like clay, silt, sand, and coarse materials, and soil classification, Atterberg limit, liquid limit, plastic index, sinkage limit, etc. Unconfined compressive strength, shear test, Tri-Axial and box direct shear test, consolidation test. Besides this, there are many other tests like lot of chemicals test, permeability test, angular repose, etc. Many other tests are there. As I know, soil is consisted of three state matters: solid, liquid, and gas. Solid is soil particles, liquid is water, and gas is air. We can easily separate the solid and liquid by determining the soil moisture. But to determine the air space, we must determine the voids in the soil mass. Many people ask many questions. When it is saturated condition, 100% saturated condition, underwater condition, how water shall be there. But analysis gives that all spaces are not covered by not filled up by the soil moisture. Some spaces there which is yet to fill with water. So we have to very much sincere about the testing procedures and preparation of test import, test specimen spatially. We shall discuss about the soil moisture. Soil moisture is, although it is appears to be very simple test, it has lot of influence in practical geotechnical engineering. Soil moisture is directly related to strength parameters too. We can find out the soil moisture just oven drying the soil specimen, test specimen, 105 degree at 105 degrees centigrade for 24 hours or little more for evaporating the water from the soil. Or instead of 105 degrees centigrade, we can reduce the temperature and keep more times, it will be more better because the, there are chances of overburning of soil. So appropriate care shall be given at the time of oven drying of test specimen. This is the relationship of soil moisture content, that is in place of water in the soil mass and solid. It is 10 square means it is a percentage. This measure has directly related to voids and strength in relation with liquid limit and plastic limit. A0. By this, you see, by this, I have recommended that by this soil moisture, not in percent, into specific gravity in the void ratio. From this void ratio, we can calculate again other parameters also. So, it is directly related with strength and consolidation too. The soil density may be calculated as the ratio of the weight of soil to the volume of soil. The undisturbed tube sample shall be extracted out for the sampler and selected piece may be prepared as test specimen after properly sanctioning, taking a measurement and necessary surfacing. We must be careful to prepare the test specimen. If the surface is not even, our entire purpose will become useless. So we should very careful to prepare the test specimen of measuring the diameter, length and weight. Now we can calculate the bulk density or bulk unit weight or weight density or weight unit weight. That is denoted by gamma W, weight of weight soil by volume in gram per centimeter cube. If it is in gram per centimeter, that can be converted to ton per meter cube. The volume is a test specimen, which is, since it is cylindrical specimen, pi r square L or pi by 4 d square L. The dry density, it is used in overburden pressure and other effective pressure above water level. This dry density is essential parameter. It can be calculated from bulk density and soil moisture. Bulk density divided by 1 plus soil moisture, not in percent. We can calculate the bulk dry density from bulk density. The void ratio, we can calculate the specific gravity by dry density minus 1 and total void, that is porosity, we can calculate from void index, void ratio itself. Void ratio divided by 1 plus void ratio, it will give us total voids, that is porosity. There is a provision of application of submerged density below water level, and I told that the above water level dry density is necessary and below water level we require submerged density. For submerged density we have to calculate the saturated density first. Saturated density equal to specific gravity plus void ratio divided by 1 plus void ratio. And thereafter, submerged density, we can simply deducting the density of water, that is submerged density, gamma S is submerged density minus 1, since density of water is 1. I see in some works of some people, they are simply deducting this saturated density from bulk density. They have deducted this from this bulk density. They deducted the density of water, and they are getting they are considering it submerged density, but it is not submerged density. Today soil is not saturated, tomorrow soil will be saturated. So we have considered saturated density only, not bulk density. You see, as I told earlier, the test specimen preparations, we must be careful for test specimen preparation. These are the extracted soil samples for drying, and after drying it shall be making powder using this mortar and pestle. We are making powder, and these are the just extracted out, taking some specimen for testing directly and others dried for other tests. The test specimen after extraction visually should be analyzed properly before drying. It is more preferable for drying the soil specimen inside the room without direct contact of sunlight. After drying at room temperature, the specimen shall be made powder using mortar vessels, and thereafter keeping it oven for complete drying. Careful observation is necessary during oven drying process to avoid overburning of this specimen. Now, let us discuss the test specimen. As soon as the test specimen shall be ready, we should go for directly for sieve analysis. This is grain size analysis. This up to 0.75 micron that can be tested in sieve analysis, and beyond that we shall have to go for sedimentation test and specific gravity test. Specific gravity is a very simple test, but it influences everywhere there. In geotechnical engineering, influence of every parameter everywhere there. So this test, sieving test, specific gravity test, hydrometer test, limit test, this test we can conduct generally on dried sample. We should not forget that the limit is a special type of shear test which has a very close relationship with shear strength like S of soil, besides adequate information of consolidation state. First studied by this limit test is first studied by a Tarbag, a Swedish scientist, in 1911. That means before popularization of soil mechanics, this test was studied by Atterberg. Besides the direct state of soil, different state of soil and classification application, the following relationship is most valuable output. One is liquidity index, soil moisture, liquid limit divided by plastic index. That is, plastic index is WL minus WP, that is plastic index, and liquidity index is soil moisture minus liquid limit by plastic index. Another important is relative consistency or consistency index, IC or RC. Liquid limit minus soil moisture by IP. Here you see, here when the soil moisture is here at this liquid limit, the strength will be 1.7 kg cm square. Say strength will be 1.7 kg cm square per centimeter. And when this liquid limit soil moisture is at liquid limit, shear strength is almost 0 or 1.70 gram per centimeter square. 1.7 gram and 1.7 kg. The difference is how much? It is kg, it is gram. Thousands times difference. Slightly variation of soil moisture, the strength can vary thousands times. It is in kg, it is in gram. So, or we can calculate the RC 1 minus liquidity index also. 1 minus liquidity index. That is, if RC is 1, shear strength is this much. RC is 1, shear strength will be 1.7 kg. If liquidity index is IL is 1, the shear strength is 0. So when soil moisture will be here, it will be 0. In this liquid limit, the soil states have been divided as solid. This is soil. When soil moisture will be at increased limit, this portion will be solid. There shall be no volumes increase. And this is semi-solid. When the soil moisture from here to here onward, this shear strength will be 1.7 kg. Here onward, if soil moisture is from WP to towards liquid limit, then it will be here, it will be 1.7 to 0. The type of shear, you see, type of shear. When the soil moisture will be here or less, here will be shear failure shall be the governing criteria. Yes, there will be no settlement failure, there shall be shear failure. If soil moisture in this portion, this elastic failure. Elastic failure. If we release the load, it will be again take its original position. If we apply the load, it will little volume change will be there. Not exactly volume change, elastic compression will be there. And here it is. If the soil moisture from this point to this point, then it will be consolidation failure. Consolidation failure means it shall be governed by settlement criteria, not by shear criteria. Another important thing is this limit, this liquid limit, also related to compression index. Most important parameters in geotechnical engineering, which is basically we are dependent on compression index for establishment of relationship of settlement and load of the structures. This is for 008, the liquid limit minus 10%. And somebody use it is a liquid limit 20%, it is at 0.007. Some say it will be 9, it will be 15%. And there are so many relations with the plastic limit also, but this equation is adopted by Indian standard 2. Besides this, limits are used for classification of fine grained soil. Fine grained soil means those who are silty, clayey soil. Clay and silt, that is silty, clayey soil. There is a line. There is a line which is calculated. This plastic index is calculated as 0.73 WL minus 20 as A line. If plastic index, say it is the A line, let us consider this is the A line. If plastic index is above this A line, the soil is clay. The clay is governing material. If plastic limit is below the A line, it is silt. The silt is deciding and governing material. So another is, if liquid limit is less than 35, it is classified as low plastic, like Cl, Ml, Ol. If plastic limit is 35, more than 35 and less than 50, then it is medium plastic. This is Ci, Mi, like that. And more than 50, it is high plastic, CAs, MAs, like that. This A-line criteria is not accepted globally. In some countries, they are dependent on the other characteristics like stickiness, glossy, luster. On this type of character, they have decided, and this classification system made. Grain size particles are also used for estimation of bed scour for hydraulic structures like bridge, river bed training works, protection works, guide banks, etc. also. The granular soil are basically classified on grain shape and sizes only. If it is single grained, poorly graded like SP, GP, these are the grade. And if it is multiple grain particles, multiple grain materials, that is termed as well graded. That is sheet SW, GW, like that. For this purpose, from the visual observation also, from this shape of the curve, one can decide. But there are some coefficient of uniformity and coefficient of curvature using 60%, 30% and 10% particle sizes. We can calculate the either poorly graded, single graded, or multiple graded. Single graded means poorly graded, multiple graded means well graded. All type of materials are there. These particle sizes used Colonel Lacey, former principal of Thomason College of Turkey. He had studied for Sindh River, and using 80%, 50% and 20% sizes, he determined one factor, sill factor. It is timed as Lacey's sill factor, and his regime theory was used his sill factor only, which is from mean particles 20% size, 50%, 80%. That is the average of these mean particle sizes, and 1.76 root over mean particle sizes. This is Less's Sill factor. And using his regime theory, we can perform, we can design and analyze the well foundations and protection works, guide bound, any other hydraulic structures. Now, let me discuss little about unconfined compressive strength test. Normally it is UCC, unconfined compressive test. Nowadays people prefer to say it inertial compressive strength, inertial compression test. In rock mechanics, it has already been said that UCS, but in soil mechanics, it is yet to change. But popularly renamed as inertial compressive test. That means unconfined means here there will be no confined pressure, there will be no confinement. It will be completely open with air. The load will be applied here. Resistance will be equal, resistance will be here. That is the base of the test specimen. I had already said that the surface of this test specimen, both top and bottom, so smooth, it should be so smooth, there shall not be any difference. A fraction of a millimeter, may lead to a serious results. So it should be we should be very careful of preparation of test specimen. If test specimen is not correct, entire process will be misleading for us. So this is, we are applying load, there will be some deformation, ultimately this specimen shall fail. There are three types of failure. If it is a very hard soil, there will be some diagonal failure will be there, which angle shall be 45 plus 5 by 2. This will be diagonal failure. That means the soil shall be behave, shall be fall under general failure criteria, and settlement shall not be governing factor here. Settlement will be much less, shear will be governing factor. Another failure is that there will be some hair-like crack inside inside the test specimen. There are some hair-like cracks. This is called brittle failure. It is not shear. There is a brittle failure. This will be, the soil is not so hard, but it is not soft. Another is the volume is decreasing. There will be no shear at all. The volume will be decreasing with sufficient lateral expansion. When the volume is decreased, what happens? Lateral expansion will be there. So here the volume will be decreasing, the length will be decreasing, volume will be same. So it is called plastic compression failure. Plastic compression failure. Here the settlement criteria will be deciding factor. That is very soft soil. That means very soft soil. It is not, I do not say it is not suitable, but it is costly proposition. This is the test, how to carry out this test. There is no confinement. This one is loading gauge, another is strain gauge. Loading gauge, strain gauge. Strain gauge, we can measure the displacement, we can measure the shortening of the test specimen. From the loading gauge, we can calculate the applied stress. From these dial readings, we can calculate the failure length from the strain dial reading, and we can calculate the failure area also. Because our volume is constant, we do not describe the volume. Volume is constant. The failure is there. So area, we can calculate the area. It is failure area. Stress per divided by failure area. Stress per failure area is our compressive strength. That means P by A. A means failure area. Further, from this stage we can calculate elastic modulus, that is Young modulus, shear modulus, spring constant, Poisson ratio, we can calculate. These are very useful information. Elastic modulus for elastic settlement analysis required, Poisson ratio also elastic settlement required, and spring constant required for machine foundation designing with Poisson ratio, and shear modulus in dynamic loading condition we require the shear modulus. So all these things we can calculate from this test. In earlier days, shear strength S equal to assume as half compressive strength. That is S equal to C tan 45 plus 5 by 2. And C, since failure is 45 by 5 by 2, so therefore C equal to half compressive strength, which is equal to S, where alpha, this failure angle shall be 45. Further, SBC also earlier calculated from compressive strength only. This test is very simple, but it has multi-purpose uses. Next addition of unconfined compression strength is Tri-Axial shear test. First introduced by Tarjagi and Kasagandi in 1936 in USA, which globally become most popular and essential test in geotechnical engineering. Tri-axial means we are applying three-axial load. That is sigma 1, we are applying pressure, and sigma 2, we are getting equal reaction from this base. Sigma 3, our lateral pressure. Lateral pressure, we are considering our soil has some lateral support, which is normally we consider it overburden pressure. So, in this shell assembly, we are applying water pressure here. With a water tank, we are applying the water pressure here, and a rubber membrane was provided here not to disturb this specimen, So, I do not know why it is triaxial. It should be two axials. This axials is action, this is reaction. It is not loading. It is only two-side loading. It should be, instead of three axial, it should be two axial. We do apology to all. S equal to sigma 1. That is sigma 1 and sigma 1 equal to sigma 2. Sigma 3 minus sigma P. Sigma P is the pore pressure. If we neglect the pore pressure, sigma 1 minus sigma 3 is the strength, shear strength. Considering a sigma 1 as the resultant force of cohesion, that is mutual bondage of particles and intermolecular friction of particles, so it is S equal to C plus N tan phi. That is C N tan phi, tan 45 by 5 by 2, approximately N equal to sigma 3. That is, actually we are providing N instead of sigma 3. Considering sigma 3 as our overburden pressure, lateral pressure. we have to finally draw these three curves. It's the earlier preposition, we are old man, I am 80 years now, so I do not use the recent software method. I am hesitating to use. In my opinion, this method is best. This C5 value are later used in further analysis like SBC, retaining wall, deep excavation. Normally people thought that why deep excavation C and 5 value is required, because the depth of excavation is directly related to C and gamma and angular repose. So it is required for deep excavation also, pile load capacity, scour depth also in case of cohesive bed, and lot of information we can gather from the C5 results. The compression, unconfined compressive strength and Tri-Axial shear strength gives us details of our soil strength, shear characteristics of soil, especially for silty clay soil. In case of granular soil, neither Tri-Axial shear test could be conducted nor unconfined compressive strength test can be conducted. Under this, the other parameters like elastic modulus, shear modulus, spring constant, Poisson, etc. also estimated considering the stress-strain relationship. In establishing the lateral strain, we assume that the original volume of the test specimen is constant. Only we have to calculate the new length and new diameter and length we have to calculate to get this test results. In granular cases, we cannot go for Tri-Axial shear test and unconfined test. Box shear test is alternative solution for some granular soil. However, as I feel, box shear test reflects much higher values than other field tests like SPT and relative density test. In my opinion, estimation of frictional angle phi from SPT from the original works of Tarzaghi and Kasagande, which are worldwide accepted, is much better than the box shear test. We also remember the 1 degree variation of phi gives us a total cost variation of foundation is 18%. For say 1000 crores project, 1000 crores project in foundation cost if 18% is increasing or decreasing, what shall be total loss or total savings? So we must be careful to find out the phi value. 1 degree phi is variation makes you 18% total foundation cost result. So we should think about this. The unconfined compression test, Tri-Axial shear test, box shear test as discussed above shall serve our strength purpose. There is another most unfavorable thing. Test is consolidation. Initially, one-dimensional consolidation test was introduced and later on, three-dimensional test also introduced. This is consolidation. It is a very long, cumbersome process. Decrease in volume under static loading is compressibility. Because here, when we load it, the volume will be decreasing because it is still mold is there where we are loading. You see this consolidation audiometer. This is in consolidation test. Volume is decreasing under static loading. On the other hand, volume decreasing under dynamic loading is termed compaction. In both cases, volume decreasing. When it is under static loading, it is compression, it is compressibility. When it is under dynamic loading, it is compaction. Compressibility is the resultant of compression of solid particles, that is the rearrangement of solid particles, compression of pore water molecules, and drain out of pore water under higher loading pressure. Applied load should be greater than pore water pressure. But water is most incompressible material. And as such, drain out of pore water is governing factor of consolidation. It is therefore attempt was suggested to make attempt to dry out the pore water pressure under an initial nominal loading. Undoubtedly, this test has a vital role in foundation design and analysis, simply for fine-grained soil, silty clay soil. The derivatives are this: compression index, change in voids divided by log this final pressure by this pressure variation, which was given by from void index also 0.3, void index minus 0.30. It is also from limit also. So many relationships are there. Another is compressibility is change in voids divided by pressure changes. MV is compressibility divided by 1 plus E0. This is also another equation is there, unconfined compression, half unconfined compression test, and divided by these values, IP values. But this empirical relation gives some higher values. It gives some higher values, so we should follow these values only, this value. In addition to these parameters, consolidation rate, permeability, elastic modulus are also determined. However, compression index C and volume compressibility MV is very essential for foundation design and analysis. With all this, with some separate test, we can, instead of determining the permeability, in my opinion, permeability shall be determined at site using double Baker field permeability. Because in laboratory, in confined condition, permeability is not exactly measured. Because we remold the test specimen to a certain density and make it saturated, and with a porous plate it will be going. So instead of that, the single packer is there, but in soil, simple packer is not suitable. It should be the double packer is suitable for that test section. We must go for this permeability test. And swelling pressure test results, chemical test, etc., which are essentially not necessary in practice. However, I shall discuss all those tests in coming days. I shall hope and look forward this shall surely help you in coming days. I am always available at jcgogoi@gmail.com. Please have a nice and pleasant day. Thank you so much.